Welcome to question 4 of the 2018 Mathematical Methods Exam 1 for the Northern Hemisphere. In this video we will be looking at the solutions to this question. A reminder that this video is in no way endorsed by VCAA. So for question 4 we're asked to solve the equation log 3 of t minus log 3 of t squared subtract 4 is equal to negative 1 for the variable t. So the first thing we need to do is remember that we have a log law that says if we subtract two logs with the same base, in this case a base 3, we can simply divide the parts inside the log. So therefore this equation would be log 3, and we have t, and then we'll divide that by whatever's inside the second log, which is being subtracted away, so that will be t squared subtract 4, and that is going to equal negative 1 still. As our variable's currently inside the log, we can write an equivalent statement in exponential form, which will find that t divided by t squared subtract 4 is equal to 3 to the power of negative 1. So in that process, the base of the log becomes the new base, the number that was outside the log, the negative 1, is the new power, and this term inside the log is now by itself. So simplifying this down, we find that this is the same as t divided by t squared subtract 4 is equal to, and 3 to the power of negative 1 is the same as a third. And now we need to rearrange this equation so that all of our variables are on the one line. So next up we're going to multiply both sides by 3, which will give 3t divided by t squared subtract 4 is equal to 1. And then we're going to multiply both sides by t squared subtract 4. So we'll have 3t is equal to t squared subtract 4. And now this is a quadratic expression, so we can write this as t squared, and then subtracting 3t from both sides we'll have negative 3t minus 4 equals 0. And now to solve a quadratic equation, one of the ways we can do that is factorise and use the null factor law. So to factorise this, we're going to look for the factors of negative 4 that add up to negative 3. So therefore we can write this as t subtract 4 multiplied by t plus 1 is equal to 0. And using the null factor law we find that t could equal 4, or we find that t could equal negative 1. However, we now need to think about what values are actually allowed inside these log expressions up the top. So if we would have a look at the first term, which is log 3 of t, we would need t to be greater than 0. That's the implied domain for that term. And if we look at log 3 of t squared subtract 4, we in fact find that more than t being greater than 0, we actually find that t needs to be greater than 2. So with those restrictions in mind, we actually find that t equals 4 is the only solution to this equation.